Create custom material presets. After completing this video, you'll be able to edit a PLA material and define a per body material preset. In Fusion 360, let's carry on with the design from our previous video, CAM Additive Setup. At this point, we want to begin talking about the materials that we selected. Now, in this case, we're using a PLA with a Bowden tube, which means that the extruder mechanism is external or on the side of the actual heated end portion where the nozzle is. This has varying settings to an extruder that is designed to be built in with the nozzle, but we're not going to really get into those specific settings. We want to talk about settings in general. So we're going to begin by right-clicking and selecting Edit. When we select Edit, this is going to open up our Print Settings editor. Inside of here, we've got some general information that's going to apply to all body presets, and then we have individual settings for each of those material presets. The first thing that we want to take a look at in the general section is going to be things like the print bed temperature. This is going to be based on the material that you're using. Even though that this is a general PLA setting, some PLA materials will like the print bed a little bit hotter than 60, some will like it quite a bit lower. It really depends on the material and the manufacturer that you plan to go with. So make sure that the print bed temperature is set to whatever PLA material you're using. For me, I'm going to set this down to 45 for this example. Next is going to be the layer height, which is a direct indication of a quality. Now, if you're using a slicer that came with your 3D printer, more than likely this layer height is going to be driven by a quality setting that you use. Now, this layer height at 0.15 should give us pretty fine detail, but note that we also have individual control of that first layer. Next is the travel speed, and this is essentially the speed at which the extruder is going to be moving while it's not printing. This is going to come directly from the max setting for your specific printer. If you go above that level, or even if you go close to the max, you might find that you have a lot of jerk or acceleration movements. And when that extruder begins printing again, you may notice a bit of an issue. So this is, again, another value that you need to play around with. Spiralized vase mode is something that can be turned on if the firmware for your 3D printer supports it. It will allow you to take a solid object and then print a single trace or path around the outside of it. This works great for creating complex shapes with a very smooth transition with no seams on the outside. But again, the printer and the firmware in your printer needs to support it. We have nozzle priming settings, and at the very bottom we also have some additional settings, things like ending at the park position. One of the benefits of using Fusion 360 as your slicer, once again if the printer and firmware support it, is the ability to generate G2 and G3 arc movements. When we're talking about G-code that's used to control the 3D printers, in most cases we'll be creating straight lines even if we have curvature. That's part of the process when we convert our models to STLs or to mesh bodies. We use those tessellated models to create straight lines to connect all the curvature together. Since we're starting off with a true solid model, we can use and generate G2 and G3 arc movements for areas that are true circles or arcs. But once again, your specific printer and firmware need to be able to support that option. Now that we've taken a look at the general settings, we can move into the body presets. We're going to be using the default normal and strong body presets, but note that you have the ability to create and duplicate these presets to make as many as you wish. We want to begin first by talking about the extruder. Now, the machine we have selected and most desktop machines will have a single extruder. Some machines, for example, if you selected the MJF printer, would have dual extruders on it. You could have per extruder settings. But in this instance, we want to talk about the general settings for things like the extruder temperature. We want to talk about the value here and how that relates to the nozzle size, making sure that this all matches what your physical machine has. And also various options for things like retract length and retract speed. Now, this comes with a little bit of playing around, but in some cases you might find with a Bowden tube that you need to increase the retract length and the retract speed in order to prevent some blobs or extra material being left behind as the extruder moves to different positions. I found that this information can come directly from the slicer that shipped with your 3D printer. Oftentimes the manufacturer will predefine these values and they'll be pretty close, even though they will vary from material to material. You can use that as a good starting point. Next, we're going to move over to the shell section. This is going to determine how many perimeter layers are created, the top layer, the bottom layer, and whether or not we're going to randomize the Z-seam alignment. This can help prevent having a zipper or a seam going up the side of your part, but again, it comes back to some of the other settings. Settings for the extrusion and the retraction can oftentimes have effects on these Z-seam alignments. The infill setting is going to be the big difference between using the normal and the strong preset. By default, the normal is set to 25% with a gyroid infill, and if we go to the strong and take a look at our infill settings, by default it's 50%. I'm going to set this to 100%, and then we're going to move back to print bed adhesion. Now, print bed adhesion is going to determine whether or not we have a skirt, a brim, or a raft for our part. Because we have 4 components or 4 bodies on this build platform, it will behave slightly different. I'm going to use the brim setting. I'm going to go under brims, and I'm going to say 1 brim loop and 1 brim layer. I'm going to do the same thing, moving into my print bed adhesion for the strong setting, and I'm going to set these both at 1. There are other settings that you can take a look at for things like different types of support materials, speed, travel, and tessellation. But for the most part, it's important to identify the specs for your specific machine and make sure that you are working within that range. The materials inside of Fusion 360 are going to be machine independent. So make sure that you do take a look at those settings and make sure that you do cross-reference any settings that you've been using on your machine already. Now that we've got these 2 materials set up, we're going to right-click on the material and assign body presets. I'm going to select this back body here, and I'm going to set that one as strong, and the other 3 will be set to normal. This means when we go through the process of generating our toolpaths, we should see a difference here. I'm going to go ahead and select the additive toolpath, go to Actions, and select Generate. Keep in mind that generating toolpaths can sometimes produce issues or warnings. Sometimes those warnings will prevent us from creating the toolpaths that we need to generate our parts, but in other instances, those warnings may be just simply there as information. In the case of our parts, they're relatively close together, and also they're relatively close to the edge of our build platform. Now, this typically means that we'll likely see a warning whenever we're talking about generating things like a skirt, a raft, or a brim around our part. You can see that the toolpath has been generated and there is an error here. Now, if we left click on that, we'll be able to see that the raft skirt toolpaths have been constrained due to print bed or collisions with other parts. We're going to be talking a little bit more about simulation in the next video, but with the toolpath selected, we can go to Simulate Additive Toolpath. This will allow us to see this first layer, and we'll be able to tell what happened with the brim, the raft, or the skirt. So as we rotate this around, we can see that we've got our initial piece, which is priming the nozzle, that line that's going back and forth. And then you can see if we zoom in, we've got a single line around the outside, and that's going to be a portion of our brim. As we play through this, we can get an idea of what is happening to our 3D print by pulling this up. But once again, we're going to be taking a look at this in the next video. But at this point, we want to make sure that we identify that toolpaths were created and that everything that we've done to this point has been maintained. So let's go ahead and save this, and then we can move on to the next video.